Let's look at this example from section 12.5. We're going to be looking at a problem that would involve using the counting principle, and we're also going to draw a tree diagram and then answer some different probability questions from that tree diagram. So in this problem, 2 dice are rolled, and then we're going to determine the number of points in that sample space. So to do that, we're going to use the counting principle, which would take the number of outcomes for the first event, which would be the first die, and then multiply it by the number of outcomes for the second event, which would be that second die. So for the first die, there would be 6 different outcomes, numbered 1 through 6. And for the second die, and this is regardless of whether you roll them at the same time or you roll one first and roll the next one second, the second die would have 6 different outcomes. So using the counting principle, that would say that we have a total of 36 different outcomes. Now let's draw a tree diagram to represent the different outcomes. So to do that, we're going to start with the trunk of the tree. In a tree diagram, you'll always start with a dot, and then from that dot we're going to have different branches. So the outcome for the first die would be numbers 1 through 6, and then the second die, since the outcomes would also be 1 through 6, each outcome from the first die would have for the second die the option of numbers 1 through 6. So as you look at the tree, if we were going through and listing all of the different outcomes, you would first start at this branch, and we would have the outcomes of 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. That would continue on to the second branch. So the next set of outcomes would be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. And then we would continue on and listing all of the different outcomes. So as you can see, I've gone through each one of those branches and listed all of the separate outcomes. And what you should have is a total of 36 different outcomes. So now let's use this tree diagram and answer the rest of our parts to this question. So part B said, determine the probability that a double is rolled. So as we look through, this will be our part B, the probability of a double being rolled, that would be here, here, 3, 3, 4, 4, 5, 5, and 6, 6. So the probability would be, remember that's number of successes, so number of favorable outcomes would be the number of number of outcomes that were doubles, which would be 6 out of the total outcomes of 36, which means that you would have 1/6. The probability of rolling a double would be 1/6. So let's go to the next part of the question. Part C says to determine the probability that a sum of 8 is rolled. So as we go through each one of these outcomes, let's look for the ones that would have a sum of 8. Okay, there are none here. Looks like I have a sum of 8 here. Also here. 4 plus 4 is 8. 5 plus 3 is 8. And then 6 plus 2 is 8. So 1, 2, 3, 4. The number of favorable outcomes would be 5 out of the total outcomes of 36. Okay, next part of the question, still using our tree diagram. We've gotten all of those. Determine the probability that a sum of 2 is rolled. Okay, so I think the only possibility of that happening would be if we had one die with a 1 and the other one with a 1. So part D there, the probability that a sum of 2 is rolled would only be 1 out of 36. And then this says, are you as likely to roll a sum of 8 as you are of rolling a sum of 2? So we would, the other wording of that would be, would you have the same probability of rolling an 8 as you would rolling the sum of 2? And remember that those were the two questions that we were asked. The probabilities were very different. So the answer for part E would be no.